So in this video, we're going to talk about how to solve square root equations and inequalities. So when we're working with square root equations and inequalities, you want to always remember to isolate the square root. So that's going to be a very important concept as we work on solving these problems. So whenever you solve square root equations, sometimes you get an answer that isn't actually a solution to the equation. So this is called an extraneous solution. You can test for these solutions by plugging your answers back into the original equation and checking which solutions make the equation true. So here are problem-solving steps. So you're going to start off by doing opposite operations to isolate the square root, then square both sides of the equation to undo the square root, solve for the remaining variable using opposite operations, and then plug the solution back into the equation to check for extraneous solutions. So let's try this problem. Let's try solving for x. So we need to first isolate the square root. Well, the square root's already isolated, so we're good there. So we're going to go ahead and square both sides of the equation. So that will give us 3x minus 2 equals 2 squared, which is 4. So now to solve for x, we're going to start off by adding 2 to both sides. So when we do that, we get 3x equals 6. And then now we divide both sides by 3, which gives us x equals 2. So now we have x equals 2. So we're going to go ahead and plug the solution in to check whether it makes the equation true. So we get 3 times 2 minus 2 equals 2. So that is the square root of 6 minus 2, which equals 2. So the square root of 6 minus 2, so that's the square root of 4 equals 2, which tells us that 2 equals 2, which is true. So x equals 2 is the solution to this equation. So now let's try solving this equation for x. Notice that in this problem, the square root is not by itself. There's a minus 1 right here that we need to get rid of. So we're going to go ahead and do the opposite and add 1 to both sides. So when you add 1 to both sides, you get the square root of x plus 3 equals 2 plus 1, which is 3. So now we're going to go ahead and square both sides. So when we do that, we get x plus 3 equals 3 squared, which is 9. Now to get x by itself, we're going to go ahead and subtract 3 from both sides, which gives us x equals 6. So I'm going to plug x equals 6 back into this radical, so we get 6 plus 3 minus 1 equals 2. So we have the square root of 9 minus 1 equals 2. Square root of 9 is 3. 3 minus 1 equals 2 is in fact true, so x equals 6 is the solution to this square root equation. So now let's try solving this problem. In this problem, the square root is not by itself because we have this 4 in front. This 4 is multiplying the square root, so we're going to go ahead and divide both sides by 4. So we get the square root of 2x minus 6 equals 8 divided by 4, which is 2. So now we're going to square both sides of our equation. So we have 2x minus 6 equals 2 squared, which is 4. So now we're going to go ahead and solve for x by adding 6 to both sides. And when we do that, we get 2x equals 4 plus 6, which is 10. Now we divide both sides by 2, which gives us x equals 5. So now we're going to plug 5 back into our square root equation, and we're going to check whether it makes the equation true. So we have 4 times the square root of 10 minus 6, and we're checking if that equals 8. So we have 4 times the square root of 4 equals 8, which does give us 4 times 2, and that does equal 8. So that means that x equals 5 is the solution to this equation. So now you can go ahead and pause the video and try this problem on your own. So here's the solution. So you're going to start off by isolating the square root by adding 3 to both sides. Then we square both sides of the equation, and then we work on solving for x, which gives us 12. Once we find the answer of 12, we want to plug it back into the original problem and check whether it makes the equation true. It does in fact make the equation true, so we know that 12 is a solution to this problem. So now let's try this problem. We have the square root of 5x minus 1 plus 1 equals 2x. So we want to once again isolate the square root, so we need to get rid of this plus 1. So I'm going to subtract 1 from both sides. And when I do that, I get the square root of 5x minus 1 equals 2x minus 1. Now I need to square both sides of my equation. So when I do that, I need to be careful, okay? So none of this 2x squared minus 1 squared, okay? The whole thing is being squared, so we have to square that entire binomial, okay? You can't just square each term individually, so be careful with that. So I end up getting 5x minus 1 equals 2x minus 1 squared. Well, now I need to expand out this 2x minus 1 squared, okay? So you may do that using FOIL or the box method. So I'm going to review how to do this by FOIL. So remember, 2x minus 1 squared equals 2x minus 1 times 2x minus 1. So first we multiply the first two terms together, right? 2x times 2x. So that gives us 4x squared. Then we go ahead and we multiply the outside terms, 2x and negative 1, which gives us negative 2x. Then we multiply the inside terms, so negative 1 and 2x, which gives us negative 2x. And then we multiply the last terms, which are negative 1 and negative 1, which gives us positive 1. So now we add up all our terms, and we're going to combine these two like terms in the middle. So we have 4x squared minus 4x plus 1. So we're going to go back here, and we're going to write 5x minus 1 equals 4x squared minus 4x plus 1. So now this is a quadratic equation. Remember, we need to set quadratics equal to 0, right? We need it to be ax squared plus bx plus c equals 0 in order to solve the quadratic. So to set this equal to 0, I'm going to start off by subtracting 5x from both sides. When I subtract 5x, be careful with that, because remember, on the right side, it's only going to combine with the x term, right? I can only combine like terms, so only minus 4x and negative 5x will combine, it's giving me negative 9x and then plus 1. So now we're going to add 1 to both sides because I'm still not having an equation set equal to 0. So now, finally, I have 0 equals 4x squared minus 9x plus 2. So when I write this equation over here, my 4x squared minus 9x plus 2 equals 0. Remember, 4 is the value of a, minus 9 is b, and plus 2 is c. So I can solve this equation now by factoring. Remember, I can write a times c. So in this case, a is 4 and c is 2, so a times c is 8. 8 is a positive number, so when AC is positive, I know that I either have 2 positive factors or 2 negative factors. Well, b is negative, so since b is negative, both of my factors are going to be negative. Now I just need to list out the factors of 8. So the factors of 8 are 1 and 8, 2 and 4, and now I'm going to make all of these factors negative. So when I do negative 1 plus negative 8, that gives me negative 9, which is what I need, right? So that means that negative 1 plus negative 8 is the correct combination of factors. So I can write this as 4x squared minus 8x minus 1x plus 2 equals 0. And what I can do now is I can factor this by grouping. I can form two groups of factors. So I have 4x squared minus 8x, and then plus I have negative 1x plus 2. And I can find the GCF of each group. So if I look at the first set, the GCF is 4x. And then if I divide out that 4x from both terms, I am left with 4x times 4 and 4 cancel, and then I have just x. And then minus 8 over 4 is 2, and then the x's cancel. And then here in the second set, I can factor out a negative 1. So I have negative 1x over negative 1 plus 2 over negative 1. And so that leaves me with minus 1 times negative 1x over negative 1 is just going to be x. And then plus 2 over minus 1 is going to be minus 2, and that equals 0. So my factored equation is now 4x minus 1 times x minus 2 equals 0. So now I need to solve this, right? I have 4x minus 1 times x minus 2 equals 0. So I'm going to set each factor equal to 0. 4x minus 1 equals 0 and x minus 2 equals 0. If 4x minus 1 equals 0, I'm going to add 1 to both sides, giving me 4x equals 1. Divide both sides by 4, which gives me x equals 1/4. X minus 2 equals 0 means I'm going to add 2 to both sides. So I get x equals 2. And so now I need to check both of my solutions, right? I want to check for any extraneous solutions. So I'm going to go back to this square root of 5x minus 1 plus 1 equals 2x. So I have square root of 5x minus 1 plus 1 equals 2x, and I'm going to plug in my solutions. If I plug in x equals 1/4, I get the square root of 5 times 1/4 minus 1 plus 1 equals 2 times 1/4. So when I multiply this out, I get the square root of 1.25 minus 1 plus 1 equals 2 times 1/4 is 0.5. So the square root of 0.25 plus 1 equals 0.5. The square root of 0.25 is 0.5, so 0.5 plus 1 equals 0.5. So that gives me 1.5 equals 0.5, which is not true. So that means that 1/4 is my extraneous solution. Now let's try x equals 2. So if I plug in x equals 2, I get the square root of 5 times 2 minus 1 plus 1 equals 2 times 2. So that gives me the square root of 10 minus 1 plus 1 equals 4. The square root of 10 minus 1 is 9. So the square root of 9 plus 1 equals 4. And so that tells me that 3 plus 1 equals 4, which is in fact true. So that means that x equals 2 is the only solution I have to this square root equation. So now you can go ahead and pause the video and try this similar problem. So once again, we're going to isolate the square root by subtracting 1 from both sides. So when you subtract 1, you get x plus 5 equals x squared minus 2x plus 1. So once we have this quadratic, which we've done by expanding out the x minus 1 squared, we're going to now set it equal to 0. So when we set it equal to 0, we get x squared minus 3x minus 4 equals 0. So when we do this, we need two factors of -4 that add up to -3. When you have a negative a times c, you're going to make one factor positive, one factor negative. The bigger factor of the two is going to have the sign of b. So you can see in this case, b is negative. So that's why I made my bigger factor in all of these sets negative. So when I add them together, 1 and -4 gives me the correct combination. So I have x plus 1 times x minus 4 equals 0, which gives me two potential solutions, x equals -1, x equals 4. So now I plugged both of these solutions back into the problem, which showed me that x equals -1 is an extraneous solution and that x equals 4 is the only solution to this equation. So now let's expand this idea and let's solve some square root inequalities. So to solve square root inequalities, you're going to start off by replacing the inequality sign with an equal sign. And then we're going to do the same steps we've been doing, opposite operations to isolate the square root, square both sides, solve for the variable, and test extraneous solutions. Then we're going to test some values around the solution in the original inequality to determine the solution set. We're also going to have to consider some domain restrictions before we can write our final answer. Remember, when we're working with square roots, we have to think about those domain restrictions because we can't have negative values under our square root. So let's try solving this problem for x. So let's first start off by turning this into an equal sign. So we have the square root of x plus 7 equals x plus 1. So we're going to go ahead now and square both sides. So that gives me x plus 7 equals x plus 1 squared. So now I need to expand out this x plus 1 squared. So to do that, I'm going to have to do x plus 1 times x plus 1. I'm going to FOIL it. So first times first gives me x squared. Outside is x times 1, which is just x. Inside is 1 times x, which is just x. And then last is 1 times 1, which is just 1. So I have x squared plus x plus 1, which gives me x squared plus 2x plus 1. So I'm going to go here and I have x plus 7 equals x squared plus 2x plus 1. And so now to set it equal to 0, I'm going to start off by subtracting x from both sides. So that gives me 7 equals x squared plus x plus 1, because 2x minus x is just going to be 1x. And then I subtract 7 from both sides, which gives me 0 equals x squared plus x, and then I have 1 minus 7, which is minus 6. So now I have this quadratic, x squared plus x minus 6 equals 0. So now I have negative 6, and I need two factors of negative 6 that are going to add up to x, which remember is like a 1x, okay? So since I have a negative number as my product, I'm going to need a positive factor and a negative factor. Since b is positive, I need my bigger factor to be positive. So let's list out the factors of 6. So we have 1 and 6, 2 and 3. I'm going to make the bigger factor positive, smaller factor negative. So when I add these together, negative 1 and 6 is 5, so that won't work. Negative 2 and 3 is 1, so that is going to be the combination that I need. So I have x minus 2 times x plus 3 equals 0. So that means that x minus 2 equals 0, which means x equals 2, or x plus 3 equals 0, which tells me that x equals negative 3. So now I have my two solutions. I need to check for any extraneous solutions. So I'm going to start off with the 2. So I have 2 plus 7 equals 2 plus 1. So 2 plus 7 is 9, so the square root of 9 equals 3, which does tell me that 3 equals 3, so this is a good solution. X equals 2. Now let's try x equals negative 3. So that gives me the square root of negative 3 plus 7 equals negative 3 plus 1. So that tells me the square root of 4 equals negative 2. The square root of 4 is 2, so 2 does not equal negative 2. So negative 3 is an extraneous solution. So I'm just going to work with the x equals 2. So now I have this x equals 2, and I'm going to go to my number line. Okay, so this is the time I'm going to bring back my inequality. So I have the square root of x plus 7 is greater than or equal to x plus 1. And so what I'm going to do is I'm going to draw 2, and I'm going to pick numbers on either side of 2. So maybe over here I'm going to pick 10. I'm going to start off by plugging in that 10. So I have 10 plus 7 is greater than or equal to 10 plus 1. So that tells me the square root of 17 is greater than or equal to 11. The square root of 17 I'm going to do on my calculator. That is about 4.1. And that is telling me that's greater than or equal to 11, so that's false. Now I'm going to try a number to the left of 2. I'm just going to pick 0. So that gives me the square root of 0 plus 7 is greater than or equal to 0 plus 1. So that tells me the square root of 7 is greater than or equal to 1. The square root of 7 is 2.6. And that is greater than or equal to 1, so that is true. So that's telling me that numbers this direction, okay, numbers less than or equal to 2 do make this inequality true. Well, so far I have a star x is less than or equal to 2. But another thing I need to consider when I do this are my domain restrictions, okay? Because every number is not just going to work because I'm working with a square root equation. Remember, since I have a square root, I want the number under the square root, so I want this x plus 7 to be greater than or equal to 0. So when I solve that, I subtract 7 from both sides, and that tells me, well, x has to be greater than or equal to negative 7. So now I have two boundaries, right? I have this negative 7 and I have 2. So I know that the number I'm talking about is going to be less than 2, but it's going to be bigger than negative 7. So if I write that as a combined inequality, I have negative 7 is less than or equal to x, and x is less than or equal to 2. So that is how I describe the solution to a square root inequality. Okay, so remember, you always have to think about the domain restrictions. So now you can go ahead and pause this video and try this problem, which is very similar on your own. So we started off by turning this into an equals. So we solved it as though it was an equation. And then once we get this, we expanded out the x minus 5 squared. Once we expanded out the x minus 5 squared, we went ahead and subtracted x and then subtracted 25 to set our quadratic equal to 0. So this is a different sort of quadratic. The c value equals 0. So we can actually solve it by finding the GCF. So what we did is we factored an x out of both terms, which gave us x times x minus 11 equals 0. So now you can set each factor equal to 0. So that means x equals 0, x minus 11 equals 0. So x equals 0 or x equals 11. Then we tested both of these solutions and found that 0 is our extraneous solution. So that doesn't make the radical equation true. So x equals 11 is the solution, so we went ahead and worked with that. So since x equals 11 is the solution, we picked numbers on either side of 11. So we picked 20 and 2. Plugging in 20 made the inequality false, but plugging in 2 made the inequality true. So we know that numbers that are less than 11 make our inequality true. However, we also have to consider our domain restriction. Remember, the number under the square root has to be greater than or equal to 0. So when we did that, we said x plus 25 is greater than or equal to 0, which told us that x is greater than or equal to negative 25. So negative 25 is less than or equal to x, which is less than or equal to 11, is the solution to this problem. So sometimes you will see square root equations in word problems. That's because a lot of real life applications involve square root equations. So we're going to use our strategy for solving word problems. Whenever you see word problems, you want to go through this 4-step process that'll help you organize all the information that you have. So always start off by understanding the problem. It's a good idea to underline, circle, or outline important information and define any variables. Then you make a plan. Usually when you make a plan, what you're going to be doing is setting up an equation that will help you solve the problem. You can use any formulas that you need also in this step. Then you go ahead and solve. Remember to always check your solutions. And then when you're talking about real world problems, you want to reflect. Okay, you want to make sure that your solutions make sense in the context of the problem. So for example, if you're trying to find the number of people that are visiting a picnic and you get a negative value, you know that you need to go back and check your problem because you can't have a negative number of people. Okay, so we're going to use this 4-step process to kind of organize how we solve word problems. So let's apply some square root equations and inequalities to solve word problems. So just summarizing what we talked about, read the problem carefully, identify variables, determine any equations or formulas, then solve and check. So let's try this problem. It says you can estimate the speed s in miles per hour at which a car is moving when it goes into a skid using the formula s equals the square root of 21d, where d is the length of skid marks in feet. During an accident, a driver claims to have been driving 42 miles per hour. If the driver's estimate of his speed is accurate, how long would the skid marks be? Okay, so a lot going on in this problem. So we have speed s in miles per hour. And here is a very important formula that we have. D is the length of the skid marks. And a driver claims to have been driving 42 miles per hour. So let's go ahead and let's define our variables. So they're already given to us. We have s equals the square root of 21d. So s is speed. D is the length of those marks. So we want to find, so we're trying to figure out what we need to find, right? We want to know the length of the skid marks. So we're trying to find D, okay? And it gives us some information. It's giving us that the speed equals 42 miles per hour. So we can use this formula that we have. So let's go ahead and set up our problem. We have this s equals the square root of 21d, and we're given that s is 42. So we have 42 equals the square root of 21d. So now this is just a square root equation. So we know how to solve this. We can go ahead and square both sides. So 42 squared is going to be 1764, and that equals 21d. Now to solve for d, we're going to divide both sides by 21, and that gives us 84 equals d. So this is telling us in miles per hour, and it says d is the length of the skid marks in feet. So that means that 84 feet is the length. Remember, you always want to go back and check your solutions. So we're going to say 42 equals the square root of 21 times 84. And that's telling us that 42 equals the square root of 21 times 84, which is 1764, which does check that is true. So we know that our solution is correct, and 84 feet is a reasonable value, right? It's positive. It makes sense in the context of the problem. So in summary, remember to solve square root equations and inequalities, you want to isolate the square and then square both sides of the equation. Then you're going to solve for the variable, check for extraneous solutions. For inequalities, you're going to plug back into the original problem to determine the solution set, and you're going to think about domain restrictions. Remember, we always want the value under the square root to be positive.